friction creates heat, creates little ice tunnels. The warm air rises to the top and begins to melt the glacier from the bottom. So, a lot of what we're sitting in currently is freshwater. The freshwater is less dense than saltwater. The saltwater has all that dissolved salt into it. So there's actually like a layer of freshwater sitting on top of the layer of saltwater. A little bit of mixing in the middle, but primarily we're sitting in freshwater here. This is a cool glacier. You can just barely make out the lateral moraine, the kind of dirty line on the side of the glacier on that left side over there. So that's as the glacier is moving. This is one of the more active glaciers in this area. It's actually the southernmost tidewater glacier in the entire northern hemisphere.
Southernmost what?
Southernmost tidewater glacier. So tidewater glacier is a glacier that goes directly into the ocean versus a valley glacier, which is just carving its own valley and empties out onto the land, versus like a hanging glacier, which is one that was part of a valley glacier and curved over the top of a mountain and broke off. Is now its own glacier sitting up high in the mountain. Versus the Cirque Glacier, it's a whole different thing. Go ahead.
Why is it so jagged? I would have thought it was just smooth.
So yeah, they're super jagged. They have what's called crevasses that generate in them. So they generally melt from the bottom, but they melt a little bit as well on the top. So when the water goes down into the crevasses, it freezes and thaws, just like everything was kind of open. As the glacier funnels out, the salt water is eroding it slowly from underneath. So it's kind of creating, like this, and then this is so dense that it'll chip off and break and fall. Once it reaches its kind of threshold, crux point, it'll just break and chip off. And just so much pressure is happening that it's just kind of this cracking and fissuring apart. This is one of the more active glaciers, I think, in all of Alaska, as far as I know of. That's why there's so much ice in the water.
Have you ever seen any of the calving?
Not in this one. This is my first time ever here. So I'm stoked to be here. I think most people on board, we rarely ever get to come to this place.
Yeah, the captain was telling us
as far as I know, never came here till last fall.
Yeah, he said this is only the second year.
Yeah.
So then we came here. Why? Right at the outlet, about 10 miles back, 12 miles back. There's a shallow spot. It's pretty common for there to be a sandbar at the mouth of these. It was one of their moraines, one of the terminal moraines. And the skiff drive across it fine. We anchor out there and we'll do like skip tours and stuff into the fjord. But it hasn't been charted, especially that sandbar hasn't been charted in many years. Only small research boats and day boats like excursions, not ships coming here. And so we just didn't. And then last fall, one of our captains was headed south and decided that he would figure it out. So he, as far as I know, sent a small boat in, one of these kind of boats with a depth sounder, and got some readings and said, I feel pretty confident that we can do this safely. And then he marked down, he came as far as he could up into the fjord and marked down some waypoints that we could follow, and kind of confirmed that the readings on the chart were matching the readings on his depth sounder. So we're following the Wilderness Legacy, the waypoints that they let down last year.
Which captain?
Tim Boss. Tim is willing to do many things.
Yeah, I was gonna say.
And I love taking advantage of the things he's learned and not necessarily doing them with him.
Get it to him.
All right. I can go over there. Or I can keep going that way.
Keep going.
So yeah, what's really cool what Steve was kind of talking about is so kind of what I'm talking about here with that dirty bit on the side, that's called the lateral moraine. So as glaciers move, technically for a glacier to become a glacier, it has to be heavy enough, dense enough for it to flow under its own gravity. It has to be heavy enough to move downhill. As it does that, it accumulates sediment and rocks, and it pulverizes those rocks into really, really tiny bits, so much so that they get suspended into water. but when it reaches its terminus, its final place, it leaves behind what's called a terminal moraine. So the furthest that the glacier will move out. A fjord, by definition, is a glacial carved U-shaped valley that is then filled by the ocean. So when the ocean fills over those terminal moraines, the moraine itself is just like a sediment hill, essentially, composed of mostly silt, but a lot of smaller rocks. Smaller could be the size of this boat. But the hill that we weren't willing to reach for the longest time was the remainder of that terminal moraine, which is called a glacial sill, like just an underwater hill. You can see not a terminal moraine, but a lateral moraine on that left side, which is where the glacier is using the mountain itself to carve away at the sides of the mountain and widen it out. You can actually see really well. Let's find a good example here. Easiest one to see. Man, right by the boat, there's a really good one. But this one's okay. So you see on this rock, this big triangular rock, how all of the lines are generally moving kind of like horizontally back. There's a good amount of just like scarring and chipping, and it's all kind of generally parallel to each other, working away and back. That's called glacial striations. So that's small pieces of the mountain from that lateral moraine being grooved and carved into the rock as the glacier moves one direction or the other. This